Okay, let's have a little look at this then. This question. X is a distance. So here dx dt, the rate of change of distance with respect to time, represents the velocity. And when you differentiate the velocity, the rate of change of velocity with respect to time is the acceleration. So these first and second derivatives represent velocity and acceleration. We're asked to find those values when t is 1. And we're also asked to show that this holds for all values of t in general. Right, so that's the question then. It's just differentiating sine at in the first instance. So part A, dx dt is equal to, sine goes to cos and it's the 6 comes out, 6 0.5, so 3, cosine 6t. So differentiate again, cos goes to minus sine and the 6 comes out again. So that equals, when t equals 1, 3 cosine 6 times 1, which is 6. And this one equals minus 18 sine of 6 times 1 is 6. So we need to tap that in the calculator. 3 times cos 6, 2.88. And this one, minus 18 times sine of 6, 7.91. So that's the velocity of it and acceleration when t equals 1. Okay, now I'm not sure about this one because I think I've made a mistake. I've still got that answer in for some reason. I managed to do that again. 5.03. Let's just change that then. 5.03. Okay. Show that this equals 0 then, the second derivative. So this plus 36x. So we'll start with the left hand side and see if we get 0. So the left hand side is equal to this minus 18 sine 6t plus 36 times x. Now x is equal to 0.5 or a half sine 6t, a half sine 6t. So we've got minus 18 sine 6t plus 18 sine 6t is 0. Okay, good. Now you'll notice in this question, just a point to observe, is we had x equals a function of t. So the x, we were accustomed to seeing the x on the other side, aren't we? And we're accustomed to writing y, and here on the other side we're accustomed to writing x here. So in traditional notation we'd have written dy dx, because we're differentiating of y with respect to x. So all we do is, if we're changing and using different symbols, the y was x and the x was t, so this would now correspond to dx dt and the process would be the same. So don't get confused by the use of different symbols. They're only symbols. It's the process of differentiation that's the important thing.